so I can hear you now perfectly. Okay, so what I want you to copy, okay, so this quiz on the right side in chat. So it's basically all quizzes from McGraw-Hill. When you want to review, so it's a very good resource. Okay, I will share also, okay, so can you copy this link?
Yeah.
So higher ed, so it's from McGraw-Hill. Okay, maybe I should show how it works. Okay, so basically it's McGraw-Hill textbook, and when you go from one chapter, so from first chapter to the last chapter, you will be able to select like any topic and practice. So study quiz 1, 2, 3, for example, for this chapter. When you see question, you will try to solve and then choose any answer. Okay, what do you think? And then, okay, for example, everything A, I select. You don't need to insert your email address. You don't need to provide any personal information. You just need to submit, and then you will see if it's correct or not correct and what you need to check. So how to get components and everything else. Okay. So at the end, okay. So for last chapters, you don't have quizzes, but for everything else you have. Okay. So it's good to review. Yeah. Okay, so what I wanted to show you, some online resources that could be helpful. Okay, I signed you up to CK12 and quizzes. Okay, I'll share a screen with quizzes now. Okay, okay, so I signed you up actually with your Google Classroom, and I send you a link to do this quiz on Google Classroom. Okay, can you check in your Google Classroom if it's in front of you, if you will be able to access?
Yes, just 1 second.
Mm-hmm.
The grade 11 or 12?
Grade 11.
There is many links.
Okay, so let's check which ones you will need.
Is it the graphing motion?
Yeah.
Graphing.
And basically that code is written there already. Yeah, I could share the screen. Okay, so graphing motion is basically to check if you understand the difference between DT-VT-80 graphs, how to move from one to another, which information you can get from them.
Mm.
So quizzes should give mark to your Google Classroom, but often it doesn't work. So often it's manually. So I'm setting up until you get better, okay, a few times, but it's better to get from the first time right away. Okay, so you had also some worksheets on whole grade 11. So unit 1 was on motion, kinematics, then unit 2 on dynamics, forces, Newton's laws, then energy. So usually we are going through mechanical energy, kinetic potential energy, thermal energy and nuclear energy Okay, we can touch a little bit. Then waves and sound and electricity and magnetism. So it's basically 5 units, and we need to do it in accelerated motion to be able to finish ASAP, right? Okay, so for graphic motion, when you will click on that link, you will be able to see instructions, and information with your code is there embedded. So graphic motions, when you click, it will ask you, okay, what's your parent password? You will enter, and basically it's your parents wants to see it. They can get reports, and you can see your reports anytime. Okay, so I will be able to see also how you're doing, and if it's above average or below average for you, for whole class. Okay, so it's a good practice tool, and when you will decide to practice on similar topics and do it on your extra time, different ways of practicing, like through flashcards, through playing with partner or playing by yourself. So it's nice practice. Okay, so can you click on that link and can you share screen? Okay, can you try to share screen now? Is it possible? Like, do you have option on the bottom share screen? Oh, Christopher is connecting. Hi, Mr. Christopher. I'm with Mohammed now, grade 11.
Hi, Miss Linda. I think was the schedule supposed to be 1 to 3 or 12 to 2?
You have 1 to 3, and it's in
Okay.
emails. In emails, I think it's different link.
Okay.
Um,
Okay, no problem. I will. Okay, then I'll just use that link. But did you need any assistance in this class,
no,
or you're
no,
okay?
no,
Okay.
this one is fine. It's fine. Thank you.
Okay. Got it. Okay. Thank you,
Mhm,
Miss Linda.
no
Okay.
problem.
Bye.
Mhm,
Bye.
bye. Hi, Mohammed. Did you try to share your screen? So it's on the bottom icon share. Share, and you can open your quizzes, and I can see if you're in.
Is it sharing this?
Yeah, yeah. So, okay, you are on CK12.
Sorry.
It's
On the
okay.
right side?
Yeah, but you're on CK12. I expected you to be on quizzes. CK12 is also very good practice. Okay, so it's both of them. Graphing, graphs and linear motion. I think it's second one. Is
This
it
one.
Dropbox? Yeah, quizzes. Okay. Yeah, you
Start?
can start. Sure, you can start game.
Share this.
And you can pause time from time. Maybe we can check. Okay.
Mhm. Yeah.
Yeah, because the biggest slope.
Mhm.
Mhm. Yeah, negative sign because slows down. Okay, so you didn't pay attention that it's a decreasing velocity, so negative acceleration. Object slows down.
Mhm.
Right?
Yeah. Each time. Meters.
Yeah. And it's not only one answer, so it could be several.
So constant, it means slower or faster?
Say it again. Acceleration.
It says at
Con-
constant speed.
Constant speed. So speed is the same, but it's going around the curve. So turning around with
Slower.
constant speed.
Hmm.
Speed constant, direction only changed. We will go over those answers. It's okay. So it's a concept vector and scalar. Okay, so we will check now. I will open on my screen. Mhm. Okay, and everything take practice. So the most important, consistent and recent at the end. Okay, so you can check what you answered and what it should be. Okay, so velocity. So velocity, it's a scalar vector, scalar value. It has magnitude, speed, and direction.
Mhm.
So where object is moving, so you answer it correctly, no problem. Second one, a distance per time. So distance is a scalar, time is scalar. So scalar divided by scalar gives you scalar value speed. So not force. Force is push or pull, so it will be related to dynamics. Okay, because of force, object will change direction, change size of the speed or velocity, but force will not be applied here. So you need to think about distance divided by time. So scalar by scalar is scalar speed. What is acceleration? Okay, so object changes speed from bigger one to smaller one. So change of velocity, so final minus initial. Okay, final is 300 minus initial 900, negative value, negative 600, divided by change of time gives you negative.
Minus,
Okay, so
yeah.
you were thinking, but you also, like you missed sign and unit. Okay, meter per second is what? Speed, right? And here we
Mhm.
have speed divided by time gives you speed divided by time squared. Okay, whenever you have acceleration is distance over time squared.
Of course.
So I will review and then we will try second time. How to check if it's positive acceleration. So those graph represent dt. Okay, just to make it bigger. Position time graph. So whenever you have curve, it means you have acceleration. So
Yeah.
inside or outside the acceleration. Straight line, so right away, if they ask about acceleration, D is out. So you need to look at those ones. So slope will increase. Think about attached line, tangent line will get bigger and bigger and bigger. So only for A, it's getting bigger. For B, it gets smaller this time. And for C, it's also gets smaller this time. So B and C, object is slows down. For A, object will speed up, accelerates. Okay, that's why
Okay.
A is speeding up. Okay, so a bike rider at rest heads down the road. You have final velocity. What is acceleration after 3 seconds? Okay. At rest. So initial speed is 0, final speed is 12. So acceleration will be positive. Okay, object will speed up. And now how to get acceleration? Change of velocity over time. So 12 minus 0, 12. 12 divided by 3, 4 meter per second squared. Okay.
Right.
So mass, we don't care about mass. So it's just too confused. So always try to separate what is important, what is not important. Object is in motion when it changes position. Yeah, you choose right. Greatest acceleration, so slope, and you did good. So bigger slope, bigger acceleration because it's velocity time graph. No acceleration, so it should be motion with constant speed or rest, right? So only horizontal line A shows that object time goes by, velocity stays the same. So object continues to move, doesn't speed up, doesn't slow down. So acceleration, so make a relationship. So slope of VT graph is acceleration. Okay, so what is person displacement? Displacement, it's vector that joins initial and final position. So if they ask about distance, so distance is total path. So you add, yeah, but displacement, shortest distance, yeah, and you did right. Okay, so you did right too. Also, you divided distance by speed. You got time correctly around the block. Okay, when you change direction, then even if you have constant speed, you have acceleration, centripetal acceleration towards the center of the curve. So here the concept is if you're moving with constant speed, a long straight line is uniform motion. So uniform, all is the same, direction the same, speed the same. Whenever you change direction, even if it's constant speed, you have acceleration. Okay, so velocity. So here concept of vector. So velocity is vector that shows magnitude and direction. Okay, so magnitude, distance per time, not acceleration, not only this. Okay, here miles per hour. It's a American way, so it's an imperial system, miles. But you don't have direction. That's why you can select this one. And here it's only direction for position. So where is it? So magnitude and direction for speed, like speed with direction, is your velocity. Okay. Can you try again? Second time to do it? I think I set up second time. So let me know. You can share a screen. You can do it the same.
Okay.
Play again. Yeah. Okay, so I can check on my side. Okay, so best attempt, your second attempt. Okay, so a couple, okay, 3 questions. Okay, what did you miss? Yeah, I'll share screen in a second. Mm. Just 1 second. Graphs linear motion, okay. And your second attempt. Okay, like this. Okay, so you missed that distance over time is speed, not acceleration. Velocity over time is acceleration. So how fast velocity changes is acceleration. Okay, everything is good. Measure of velocity. Okay, so pay attention on units. Whenever you have distance over time squared, it's acceleration. So it's not velocity. So velocity, it's distance over time with direction. Okay, and here. Okay, so when object will speed up or slow down? When you go from rest to some bigger speed, so you're speeding up. When you're going over bumps, so your speed will go bigger, smaller, bigger, smaller. Change of speed gives you acceleration. When you have constant speed, but you're turning, it's still curve. So it's turning around, so it's not straight line, it's not uniform motion, so you have acceleration, and slowing down to stop, so negative acceleration. Okay, so you missed one, right? First one you missed. Okay, so looks good. Okay, next one. I want you to go over another one. Okay. So 2 times. It's basically similar ideas. Okay, it will show up right now in your Google Classroom. So you can check link. So it's also about reading the graph, finding. Okay, so slope of dt graph gives you velocity. Slope of velocity time graph gives you acceleration. And if you go from the right side to the left, so how to get from acceleration velocity, find area of the graph, and area is accumulative, and from velocity time graph, how to get displacement, you find the area of the graph. Yeah, you're trying to connect. I don't see you here yet. Okay, you're thinking. Good. You can share screen. I can see how you're answering. Okay, perfect. Okay, just give me a couple minutes. I will prepare like a worksheet so we can go through those questions with calculations. Okay. Just okay, so I will share screen now. But I want to download this Word document or PDF. Questions. Okay, it will be faster when I will go through screen. To download, it's more complicated. Okay, Mohammed, are you here?
Yes.
Okay, here. Okay. So first graph. Okay, so graph represent. Okay, so you wrote that it's increased velocity. it looks like it was a position time graph. Whenever you have a distance time, position time graph, and a straight line, it's motion with constant speed. So velocity changes only when you have curve. So pay attention, like what is on vertical axis. So x or distance is basically the same. So when object is moving by the same time interval, like slope is the same, it means motion with constant speed. Okay, so first one, constant speed. Second one, runner A passes runner B. So A is top one, B next one, when you look at letters. Okay, when it will pass, it's hard to see pictures. Okay, but you answered it correctly, 3 seconds. Like 1, 2, 3. It's like point where they cross each other. So they will be on the same position. So position the same, they will meet. Acceleration for A, it's slope of the line. Yeah, you did right. So rise of run, 20 divided by 10 gives you 2 meters per second squared. Okay, this one, okay, not right. At 60 seconds, how far object traveled? $60. How far object traveled? So you are reading the graph. It's a distance time graph. So 60 seconds, it's here on the bottom. So you just read the graph. What is corresponding y value? So it's 40 meters. So object was moving 10 meters in the same direction, then stopped, then moving further at position like 40. So 40 meters passed. Okay, just reading the graph. Head start. Okay, who had head start? Blue one. So when time is 0, object that is represented by a red line started right away. But blue runner was already 10 meters ahead. So he had or she had head start. Okay, faster. Okay, you did right. It's steepness of the line. So who has higher, bigger slope? A red line. Okay. Okay, you answered correct. What happened between 2 and 3? Horizontal line. So velocity is the same. Object is not accelerating. What happens at 4 seconds? At 4 seconds, object changes direction. It was returning to initial position and then coming towards to initial position. Okay, direction changed. It's like negative slope and positive slope. Total displacement in 7 seconds. Okay, so 7 seconds, it's somewhere here. So to get total displacement, you subtract positions. So object was moving in positive direction, and here 7 seconds, it looks like below negative. So you, okay, I don't see the DT or VT graph. Okay, number 9. Okay, just number 9. Maybe it's bigger. No, it's the same. Basically, total displacement. If it's position, so velocity. So if it's velocity, area of this shape minus area of that shape. Okay, but really total displacement, yeah, it's easier to see where object is now. So 1 meter south. So usually north is up, south is down. Yeah, so you know what, without any calculation, so 1 meter south. So displacement is 1 centimeter. Okay, so change, they don't ask about direction. Yeah, so 1 centimeter. Who has the greatest average speed after 100 seconds? Picture such a small. After 100 seconds, 100 seconds, it's okay here. So you had Alex, Mike, and Caitlin. So speed is distance over time. So at 100 seconds, time is the same. So we can check who had bigger distance. So it's not velocity, it's speed. So who had bigger distance? Mike passed bigger distance for the same period of time. So Michael had bigger average speed. So it looks like distance bigger than comparing to others. Okay, so you have speed, time, how to get displacement. Okay, so they didn't say that dog was running with acceleration. So speed multiplied by time gives you distance or displacement in that case. So 7.5 multiplied by 5, close to 18.8. And they recommended this answer. Like around 7 by 5, 35. Comes to a stop. Okay, sorry. So I didn't notice and stop. So average speed multiplied by time. So one of the formulas for displacement when object has acceleration is initial speed plus final speed divided by 2 multiplied by time. So 7.5 divided by 2, it's approximately 3.25 multiplied by 5. So approximately 18 meters per second. Yeah, so average speed multiplied by time is the best formula to use there. Roller coaster has velocity, initial, final velocity, and 4 seconds. What is acceleration? So change of velocity over time. So final minus initial. Did you get it? Okay. So final 70 minus 6. So 64 divided by 4, 16 meter per second squared. Okay, so change of velocity over time. What is displacement? When it's thrown up to the height and then falls back to initial height. So it's returned back to initial position. So displacement, it's vector that joins initial and final position. So if object is going up and then returns back to initial position, so displacement is 0. So came at the initial position. A similar question could be walking around the rectangle or square and coming back to initial position, or circle. So walk around, come back. So displacement is 0. Okay. Okay, so basically here in second one, it was more application of formulas. Okay, can you try second time? Can do better? Okay, so try again. And you can share screen. Yeah, perfect. Yeah. Yeah, good. So change the velocity over time. Okay, I'll check now. Yeah, second time. Okay, so here it was distance time graph. Okay, what kind of graph? Okay, let's see. Quiz. It's velocity, VT graph. So time goes by, velocity gets bigger and bigger and bigger. Okay, so try to make like vertical lines. So when time gets bigger, velocity gets bigger. So object will speed up. Okay, so increasing velocity. Yeah, so where you made mistakes. So I will keep 2 screens open. Yeah, this one good. This one acceleration at A. Okay, first time you you counted correctly. So it was slope of the line. Okay, so look, rise over run. So 20 divided by 10. So rise over run gives you acceleration. So change of velocity over time is 2 meters per second squared. Okay. So you forgot square. So acceleration is squared. Okay, correct. Okay, who is faster? Okay, the bigger slope, the faster the object. So slope is steepness of the line. So what you can do, you can measure this horizontal line. How is steeper blue one and red one? So red is steeper. So red line is faster. Okay, this is correct. At 4 seconds, changes direction. Okay, so what is 4 seconds? Changes direction. So it goes like velocity here is negative and here velocity is rise over run. Okay, so changes direction. So goes, for example, south. If north is up, south down, goes south and then changes direction. So time goes by, it goes further and further away. So velocity increases in opposite direction. Okay, so we count the direction changed here. Okay, what you missed? Okay, this is perfect. After 100 seconds, so Mike has bigger average speed. Okay, let's check number 10, bigger picture. Mike, after 100 seconds, had bigger average speed. So for position time graph, average speed is not instantaneous at this point, for example, at some point. And average is initial plus final divided by time interval. So Michael was coming faster. Okay. So when time 100 seconds, he was already at that distance earlier. Okay, if okay. So if he was faster, okay, so distance per time, when time is the same, so if bigger distance is higher speed. Okay, probably from the graph. Okay, so here displacement. Okay, how did you do? Dog displacement. Okay, so 3 or 5 formulas for motion with acceleration. So out of 3 formulas, you can develop 2 more. That's why we say 3 or 5. So one of the formulas how to get displacement, average speed multiplied by time. So average is initial plus final divided by 5. So 7.5 plus 0 divided by 2 is 3.75, and multiply by 5 will be close to 18. So a little bit less than 4. 4 times 5, 20, and 3.5 multiplied by 5, okay, like 16 or something. Okay, so between those two values, even approximately, this one the closest. So average speed multiplied by time. Acceleration, when you have initial, final velocity, and time. So change of velocities over time for seconds gives you acceleration. So 70 and 6. So difference is 64. 64 divided by 4, 16. Okay, returns back to initial position. So started, return back. So initial position, the same as final. Okay, so displacement is 0. So it's like displacement vector that joins initial and final position. Unit for speed. Okay, meter per second. Okay, this one good. Okay. Plane have the lowest acceleration, 3 meters per second squared. Take off speed is 65. So initial speed starts from rest. Okay, so final speed is 65. Initial speed is 0. What is the distance? So distance equal. Okay, we don't have time, but we have. Okay, so time equal change of velocities over acceleration. 65 divided by 3. Okay, we can use that formula. Or, okay, what we need to find? Maximum allowed length of runway. Okay, so if in one step to solve, actually we can rearrange this formula for distance. Yeah, initial speed was 0, final 65, acceleration is 3. Yeah, because if to use this formula, you will need to do 2 steps. You need to find it first time. And it's also possible, change of velocities over acceleration gives you time. But the best way, one formula, just to rearrange for position, displacement. So change of velocity squared divided by 2a and gives you d. Okay, one more time, try it. And I want to show, like on worksheet, how to read graphs and then limit forces. Okay, so one last time. Did I set up second option? Oh, I didn't, right? It's okay. Okay, so I can do now just review on worksheet. I share it on screen. Yeah, it's okay. Yeah, it means I didn't set up. It's fine. DTVT 80. Okay. So Mohammed, I'm just wondering, like, is it possible for you when I share screen to write on that screen? Okay, we can share simultaneously.
To write on it?
Yeah, like I will try to share PDF file.
Yeah.
Okay. I think it's possible to write. Okay, you have some pencil on the top. Let's see. Okay, I'll try and then annotate. I think it's annotate. Okay, and you have on the left side toolbar. Okay. Can you try to write something? Click on the left side on the bar.
Oh, yeah.
Oh, cool. Yeah. Okay, so let's check. First one is what? Oh, let's erase. Erase. And eraser. Okay. Okay, so let's look at this graph. So it's a distance time graph for two objects, Luke and troopers. Okay, did they start at the same time? How do you know? Did somebody start ahead? Yeah, so troopers started ahead, right, by that distance. At time, 7 seconds. Okay, so 7 seconds, it means on the right side, right? So somewhere here, 7 seconds. Who is ahead? How do you know? Any idea? Or do you want me to show? Make a vertical line and see who is further. You see, for the same time, Luke and troopers will be on different position. Okay, so who is further? Who is ahead? It's 7 seconds.
Should be trooper.
For trooper, look, graph for trooper is here, and they will be at this position, right?
Yeah.
But for Luke, when you hit the line and go horizontally, it will be higher. So higher, it shows that bigger distance. Okay, so Luke will be ahead, right?
Oh, ahead. Okay, ahead.
Ahead, like
I
further.
thought who's first.
And how do you know his position further away from the origin? Like origin is here, so further
Yeah,
away
the
here.
distance.
Who is traveling faster at 3 seconds? Okay, so 3 seconds, it's earlier, right? So we can choose color. Right, so 3 seconds somewhere here. So faster at 3 seconds. So it's position time graph. Okay, so shortcut how to see DT-VT80. Okay, DT. Okay, you find slope. Okay, so here it's position time graph. So to check what is speed, so speed is here, you find slope of position time graph, and vice versa. If you have acceleration time graph, you need to get the area. Okay. And areas are cumulative. So cumulative, it means add together what is below the graph too. Okay, so for 3 seconds, what you see? For Luke is here. And troopers here. Troopers. So it means troopers will be ahead, right? So faster. Okay, ahead, but okay, they're asking about speed. So faster at 3 seconds. 3 seconds. Okay, slope of the line. So who has steeper line? Luke, right? So Luke, angle is basically slope. So slope for Luke is bigger than slope for trooper. So Luke is faster. Luke. So slope of DT graph. So it represents speed. Are the velocity equal at any time? How do you know? Okay, so do you think, is it yes or no? And how you can tell?
Yes, the time they passed out.
But passed out is distance the same. So the one is faster, one is slower. They pass by each other. They say hi and bye, and they will continue to move with different speeds. Like look, it's DT graph, right? So position time graph. So slope is speed. So the slope all the time is different. So we don't have we don't have the same steepness. So no. So velocities, no, not equal. So velocity for Luke always is bigger than velocity for troopers. So angle with horizontal line is bigger. What is happening in the intersection of two lines? Okay, they pass each other. It's like one road, one goes faster, one goes slower. It's like every second, like shorter distance, like it's diagram to represent. Okay, let's write here the first one. Okay, troopers start ahead. Yep. Yes, so think about next one. Okay, I'm trying to move the page. I don't know if it's possible or not. Just maybe I need to stop share and then I move file and then I can share again. Mhm. Okay, so this picture, just share. Okay, so a position time graph. So what you can tell about velocity? So is velocity the same or not the same? Constant or not constant? A constant is doesn't change. Not constant, object is speeding up or slowing down. So think about slope of the line. Is slope for first one and second one the same or not the same?
It's a different slope.
Different slope and constant slope, right? So it means speeds are constant. Okay, so graph are straight lines. I'm screen sharing, and am I sharing? Here, annotate. Okay. So constant velocity. Slope of graph are positive, objects are traveling in the positive direction. Positive, it means away from the origin. So usually it's north. We count like north up, south down, east, west. Steeper the slope, the graph have the bigger velocity or greater. So it means runner A is faster. So speed is bigger and constant speed. For graph B, graph is constant velocity, right? Time goes by, position stay the same. So constant velocity. position stays the same, and that constant velocity is actually 0. It's like velocity equal to 0. So it doesn't change. Okay, so rest. Slope of the graph is 0. Object is not moving. Velocity of the object is 0. Graph C and D. Slope of this graph is negative. Object is traveling. Okay, where does it travel? How is better to say? So usually we say away from home or away from reference point or towards. So traveling towards. Towards. So it's returning back to initial position, basically. So time goes by, you're closer and closer to initial position. Graph is straight, constant velocity. Okay, now look at this graph D. So what you see is some curves, right? So whenever you see curves on DT graph, it means object is speeding up or slowing down. Okay, yep. Same direction, like positive direction, yep. But the graph are not straight line, so it means accelerated motion, right? Non-uniform motion. The slope of runner A is decreasing. Runner A is, okay, and now try to think. So what happens to the slope? Gets bigger or smaller? So if slope gets bigger, object is speeding up. If object is slowing down, then slope is getting smaller. Okay, so for runner A, so whenever you make slope, like slope of the line, okay, like tangent of the line. You can imagine. So slope like this, slope like this. So slope gets smaller. So object is slowing down. Acceleration is negative. And here slope is bigger. Okay, acceleration is positive. So runner A is slowing down. And for runner B, so what happens to runner B?
It goes faster.
Faster, good. So it's speeding up. Okay. Okay, I found how, okay, but notes are coming through. Okay. Okay, I will stop and share and unshare. Maybe lines will disappear this way. Okay, so here just some concepts how to turn from one graph to another. So when you have position time graph and you need to get velocity, so you find slope of the line, right? So for runner A, so rise over run. So you can choose any 2 points, like origin is good. So vertical change is 20, horizontal is 4. So rise, 20 divided by run 4 gives you 5. It shows constant velocity. So for runner A, for second one, if you choose any 2 points, like origin and this point. So rise is 10, run is 4. 10 divided by 4 is 5 divided by 2, 2.5. So 2.5 is for second object. Okay, so speed is constant. Speed will be horizontal line. Okay, so here's some concept about instantaneous speed and average speed. So instantaneous, it's right now at this moment. For example, you have some tangent line and it looks like slope for point, this point. Okay, so like tangent line. So how to get how fast object is moving at this point? You find times 3 seconds. So rise over run is 28 minus 0. Okay, so slope is 28 minus 0 divided by change of x values, 6 minus 1.5. And it gives you slope of the line. So it's basically 28 divided by 4.5. Okay, approximately 6-7 meters per second. Okay, so let's check. So 28 divided by 4.5. 6.2. Yeah, so 6.2 meters per second. Okay, so instantaneous speed, to get, you find some point and make a line that has only one common point, and then find slope of that line. For average speed, for example, between 1 second and 6 seconds, you will join those 2 points, and you will find slope of that line. So the average, so rise over run for those 2 points. Okay, so when you join them, okay, you can select this point is nice and this point. So 36 minus 8 divide by 6 minus 2, 4. Okay, and it's basically to show that instantaneous and average speed are not the same. So car, for example, can speed up or slow down, and inside of the car you have a speedometer that will show how fast you're moving. Okay, so 28 divided by 4, 7. Okay, so 7 meters per second. Okay, so average speed is bigger than instantaneous speed. So the instantaneous, it's right now at this moment, like if you have speedometer, it will show on your device that speed. But average between 1 second and 6 seconds, like you join 2 points and you find slope of that line. Okay. For velocity time graph. Okay, and you know what? I wanted to show you videos that could be helpful to check the course. I'm pretty sure I was posting before, but just in case, it's on YouTube on physics. So it's based on our curriculum in grade 11 in Ontario. Okay, I will share this link, and then I will share screen. Yeah, so on the right side, and I will share screen now. Okay, so why I would recommend, because it's at least like the name of the topic can give you some idea of what you need to know for first unit. It's 1D motion, it's motion along straight line, and 2D motion. So when object is moving under the angle, like projectile motion. Then for chapters 3 and 4, you have Newton's laws, forces, and force of friction. So it's basically 2 chapters on motion under the forces. So in kinematics, we don't care why object is moving. We just pay attention that object is how fast, how far, how long it's moving. And in chapters on motion, on forces, we are investigating reason. So why object is changing direction or moving faster, slower, because object is under some forces. And basically we are going over Newton's laws. So first, second, Newton's law are very important. Third law, mostly theoretical. In first Newton's law, the key idea is when object is at rest, it will continue to be at rest. When object is at motion, it will continue to be at motion unless it's some force act on it. Okay, so you will be able to go through this stuff. Okay, so Newton's first and second law, then free body diagram. So it's forces that act on the object horizontally and vertically. So when object is pulled or pushed, we say that object is under some force. So free body diagram will show forces that act on the object. You don't show resultant force. The resultant, it's instead of several forces, which one force will make object to move. So if object is moving at constant velocity, we need to think constant velocity, object is not under forces. So all forces are balanced. So vertical force is balanced and horizontal forces are balanced. So in vertical direction, you have Fg, it's force of gravity. So force of gravity depends only on the weight of the object. It doesn't, okay, so weight of the object. So if you move to another planet, your weight will change because force of gravity is mg, right? And normal force is force of reaction from the surface. Force of tension, it's the same as your applied force if you're dragging the object, and force of friction is force that prevents object to move. So if forces are not balanced, then we are dealing with second Newton's law of motion, and you need to show resultant force. Okay, so if object is moving in vertical direction, so we are not dealing with force of friction. So in vertical direction, it's only force of gravity, force of tension, or applied force. But horizontally, object is under force of friction most of the time. Okay, I just wanted to show it's commercial. We'll skip. Okay, so first Newton's law. Forces are balanced. Second Newton's law, one force is bigger, another is smaller. So how to get net force? Bigger force minus smaller force equal to net force ma. And then we are using formulas for kinematics from the first chapters. Okay, so why object speeding up? Because force acts on it. So how to get acceleration? Force divided by mass. For third Newton's law, it's action and reaction, usually we call. So you're pushing on the desk is pushing on you. Okay, so two equal and opposite forces. Applying of Newton's law, usually it's outward machine and horizontal pulley. So questions for horizontal pulley could involve friction or no friction. Okay, so friction, it's force. Force of friction prevents object to move faster or slows the motion. So in some cases it's good, in some cases it's not good. Okay, so I know that he was on this course for a while, so I don't know, like, how far do you know about forces? Like, what was hard, what was not hard? Okay, so here, physics, like, good link to follow. Look, Mohammed, how much do you know about forces?
Not much.
Okay, so do you have access to the textbook?
Textbook in the classroom, right?
Yeah, in Google Classroom, and also I think I added new one because in Google Classroom it was like old textbook, like since 2000.
I see the old one only, the new
Old
one's
one.
not shown.
New one, okay. New one, just I will show you link. Put inside of one of the practice, I think inside of the CK12. Okay, you know what? I will check now CK12 because I remember I was entering that link, so it's faster than to find through my files that link.
So is it, Miss, the first link you sent?
I
The
don't
high
remember
read
which
education?
one. No, that one is just practice quizzes, but
Oh.
textbook. Okay. Oh, here, yeah. In quiz physics, graphs, and linear motion, I put in comment. But you know what? Like I copy that comment. Okay, I will show you. Okay, you see graphs and linear motion. So this in the middle, I'm copying and I will put in your link on the chat.
Okay.
So Dropbox, it's like 40 meg file. So it's text. Okay, for forces. Okay. Quick overview. Okay, so what you need to know, how to make free body diagrams. You don't make a picture of the object, you will make arrows. And for force of gravity, so it's different than mass. So mass is amount of matter in material. So how heavy or not heavy the object. So to find force of gravity, you multiply mass by acceleration of free fall. So G is acceleration of free fall. So it depends from planet. So you go to another planet, G is bigger or smaller. So for example, on Moon, G is 3 times smaller. On Earth, 9.8, right? So on Moon, it's approximately like 2.6, 3 meter per second squared. Okay, just check this about first, second, third Newton's law and force of friction. Just I need to check something. Yeah. It's a good idea, right? So most important in that part, to make a picture free body diagram and show forces that act on the object. And then just bigger force minus smaller force equal to ma. And most of the time you need to rearrange equation to find what is mass or what is coefficient of friction, or find what is acceleration of the object. For pulley problem, so when you have hanging masses, you will need for each object to find forces acting on each object, and then to write like linear system. So for one object, for another, and then solve them together. So pulley, really nice mention in those videos. And next time, like tomorrow, we'll meet from 12 till 2, right?
Mhm. Yeah.
So I will go over those problems. So try for tonight, like check, because you need to finish this faster. So I will try to go over tomorrow key ideas for chapter 3 and 4. So for forces. Okay, so try to look on the textbook, try to look on videos. Okay.
All right, miss. Yeah.
Okay, and we can do it. Like, like I was teaching summer school, like in 2 weeks, we were able to finish even exam. And here, okay, you have some idea, just put it all together and try to ask questions. Like I don't want to go over like a formulas definition. It's better you will tell me what is clear, what is not clear, and I will help you, because you need this for the next level, right? So it's not just to learn and to forget. So you